This is 7.5 notes part 2 on logarithmic equations. So a logarithmic equation is an equation with a logarithmic expression that contains a variable. You can solve logarithmic equations by using the properties of logarithms. All right, so if you have log base b of x equals log base b of y, then x equals y. We just talked about this rule the other day, and the rule that you had stated if x equals y, then log of x equals log of y, and whatever base you choose that to be. So this is sort of the flip side, but note that the base, the x and the y have to both be greater than 0. This will not work unless the x and the y are greater than 0. Okay, you also need to remember to change exponential form to logarithmic or logarithmic to exponential. So your base is your base. Log solve for unknown exponent, so the exponent is your answer. So it's base to the power of x is a. Base to the power of x is a. Again, b has to be greater than 0, but it can't be 1. Okay, now, the range of y equals b the x is 0 to infinity. If you look at this graph, if you're talking about the range, is going to the left forever, and it's coming up and sort of pushing right slowly, but it's going right forever. So the domain for our function right here, f of x equals 2 to the x, is all real numbers. And then the range is at 0. That's the low, and then y is greater than 0 or 0 to infinity. This is an asymptote down here. The graph's never going to pass 0. It's going to keep getting closer. All right, so since domain and range switch for inverse functions, that means the domain of a logarithm is 0 to infinity, and the range would be all reals. So we have talked about functions and their inverse. We switch x and y. Same thing here. All right, so how do we solve logarithmic equations? Sometimes you need to switch the log equation to an exponential form. Okay, sometimes you have to condense it by using your quotient or product rules. And sometimes you have to do a combination and sort of solve things. Okay, so look at the first problem here. I have this in logarithmic form. Is this helping me? Log base 3 of this equals 2. I can't put this in the calculator, but if I take it out of logarithmic form, it'd be 3 to the what? Second equals x minus 5. Well, that's just basic algebra now. What's 3 to the second? 9 equals x minus 5. Add 5, and what does x equal? X equals 14. Now, there is a domain idea that we need to talk about. Remember up here, I said that your x and your y have to be greater than 0. So whatever you take the log of has to be greater than 0. So what are we taking the log of? We're taking the log of x minus 5. So x minus 5 has to be greater than 0. So whatever you're taking the log of has to be a positive number, can't be 0. So add 5, and your domain is that x has to be greater than 5. So you could write x is greater than 5, or you could write in interval notation 5 to infinity. So along with solving your logs, you're going to need your domain. Does my answer fit that domain? Yes. So I'm happy with my final answer. Okay, how do you want to solve b? The issue with b is I have a log minus a log. So I can't just change this to exponential form. The only way to change it to exponential form is if I have a single log. So could you write this as a single log? No, so that's not how logs work. So just look real quick. If you think about the log of 2, and I say plus log 3, and I hit enter, this is what I get. Now, if you try to combine them because they're both the same log, like a distribution type thing, and do log plus 2 plus 3, that is a very different, I mean, it doesn't look very different, but it really is a different answer. Okay, so logarithm, the log of a number can't be combined by just putting them together, but there is a rule. We learned this rule. When you have subtraction of 2 logs, what's it lead to? A single log of division. Like, these are the rules that we need to know. The rule was log base b of m minus log base b of n. I'd write this down. Equals log base b of m over n. Now, if I had division, I could break it up with subtraction. So I need to know that rule. If I'm subtracting two logs, I can write it as the same log of m divided by n. The bases have to be the same, though. So this is log base 10, right? Now, the other thing is that there's a number out front. We'd have to put it up as a power. So I don't have that. So this is going to be the log base 10 of 45x over what? 3 equals 1. Now, we can clean this up. It's really the log of what? Equals 1. Okay, now how do I solve this? I mean, it's log base 10. I could type in the calculator. Okay, so it's really 15x in parentheses to the power of 1 equals 10. Then I just want to push that because if there's any other number, you'd have to have the power on the 15 and the x. So it really is just 15x equals 10. So what does x equal? Yeah, and if you're putting this in, for me, I'll take a rounded decimal, but if you're putting this in the program, they're going to want the fraction, unless it says to round. So x is 2/3. Now, what about my domain? Let's look at this written as a single log. 15x, what's in there, must be greater than 0. Okay, so then what? Divide by 15, yeah. X has to be greater than 0. And ours is, so we're good. Okay, now there is another rule. If we have addition, the rule is multiply. Log base b of m plus log base b of n is equal to log base b of m times n. So I'm really suggesting you write that down. We talked about how this rule connects to exponential rules, right? When you multiply bases, you add the powers, and when you divide bases, you subtract the powers. So it's a direct connection. Now here's the problem. See that 3 out front? You can't put them written as a single log because there's a 3 out front here, and it only should affect this. So we're going to reverse that rule. The other rule, I don't have really room for this, but remember the rule if you have log base b of a to the power of p, that equals p times log base b of a. Remember this rule? When you have a log to power, you bring it out front. Well, if you have a power or multiplication of that log, we can bring it up top. So this is going to be log of 8 plus.
In the parentheses or outside the parentheses?
This p?
Yeah.
It's like a power on that. And the p is times this. And log base b of a is one whole number. This is like one chunk. So this would be log base 10 of x to the third equals 3. All right, do you see what we're doing there?
So it's inside the parentheses.
For here?
Yeah.
I could show this without parentheses. X to the third is just that one piece. But if it was something like 8x, I want the parentheses to show I'm taking the log of the whole thing. Now write this as a single log. Log of 8 times x to the third equals 3. All right, now what? Does that log form help me? So the idea is we got to write it as a single log. We need to get there. Once it's written as a single log, I'm going to take it out of logarithmic form and change it to exponential. What's the base of my log? 10. So 10 to the third equals 8x to the third. Now this power 3 is only on the x, not the 8. What is 10 to the third? 1,000 equals 8x to the third. Now how do I solve this? Just basic divide by 8. What's 1,000 divided by 8? Is it 125? And then what? How do I get rid of a cube? You have two options. You can come in and take the cube root, but you got to make sure you're taking the cube root. And the cube root of 125 is 5. Or the other option is to take it to the power of 1/3. You know, if you have x to the third equals 125, you can come in. I'm trying to find another color here. You can come in and raise this to the power of 1/3 and raise that to the power of 1/3, which is essentially the same as taking the cube root because that cancels out. Okay, now there's only one answer here. If it was squared, we had the plus or minus. What is my domain here? What I'm taking the root of? I'm taking the root of what? 8x to the third. So that has to be, not root, I'm taking the log of 8x to the third. That has to be greater than 0. Divide by 8, got 0. Take the cube root. X has to be greater than 0. Not equal to, just greater than. Okay, so take a second and think about what to do with D. Okay, first thing I'm going to do is pop that power up. So it's going to be log of x to the second minus log of 4 equals 0. So it'd be log of x squared over 4 equals what? 0. Okay, my base is 10. Now my base might not be 10. It could be something else. So it's going to be 10 to the 0 equals x squared over 4. What's anything to the power of 0? Okay, so anything to the power of 0 is 1. That's important.
Okay, so x equals 2.
Well, okay, hold on here. Now, I need to get this 4 out of the denominator. So I'm going to come in and multiply out by 4. There's a little element that we need to consider here. So I have 4 equals x squared. There it is. So you have two options. Option 1 is you've isolated it, so you take the square root, but you need to remember it should be positive or negative 2. That's one way of solving it. The other way was to consider x squared minus 4 equals 0. See how I could subtract the 4? And then I would factor it. And by factoring it, I'm less likely to forget that plus or minus sign. But I did just remind you of when you take the square root plus or minus. Now, let's talk about that domain restriction. What I'm taking the log of is x squared over 4. So x squared over 4 has to be greater than what? 0. So I'm going to multiply it out, and I get x squared has to be greater than 0. And so x has to be greater than 0, right? Do both of my answers fall into that domain? No, so my answer is only x equals 2. So x equals 2 is my only answer. This one is considered an extraneous solution. Okay, so go ahead and think about what to do in this one. This one's a little bit messier. Now, in order to write it as a single log, they have to be the same base, and this one is. So wouldn't this just be x squared equals 7? All right, logarithmic form doesn't help me. I need to figure out what this is, but exponential is 4 to the 7th equals x what? Squared. I'm going to have to take 4 to the 7th and figure out what that is. That's a calculator number for me. Should be 16,384. Did anyone confirm that? Now, you have two options. You can come in and take your square root. How many answers should I get? Positive or negative? What is there a square root here that's nice?
Yeah.
What?
128.
Does anybody agree with that? Now, you actually could factor this, x squared minus that number, and you could factor it just the same. But we should get that 128 or negative 128. Let's talk about our domain. X, what's in the log that we're taking is x squared has to be greater than 0. Square root, x has to be greater than 0. So what can you tell me about the answer? That is an extraneous solution, and we only get the x equals 128. So you need to check your domain. How am I finding the domain? The domain is coming from the idea that I have log base b of x. X always has to be greater than 0. That's what your domain is. Whatever you're taking the log of, we have to make it greater than 0. Now, a lot of these domains was x is greater than 0, but is it always x is greater than 0? No. So sometimes you'll have a number there.